Scientists have just discovered what Mercury is made of after watching 8 tons of metal escape from its atmosphere. But what did they find out? And why are they so surprised by it? Let's find out in today's episode. For the first time ever, scientists witnessed a bizarre event that has been predicted for decades. A massive chunk of metal weighing over 8 tons was seen escaping from the planet Mercury's atmosphere. It was so heavy that if it were dropped on Earth, it would weigh as much as an elephant. But where did it come from? How could a planet lose so much of its mass? And what does this mean for the future of Mercury? Join us as we explore the incredible discovery that has shocked the scientific community to its core. It all started with a routine observation from NASA's Solar Terrestrial Relations Observatory, or STEREO, which has been monitoring the Sun since 2006. On January 24, 2012, STEREO detected an unusual flash near Mercury's North Pole. But it wasn't until 2 years later that scientists realized the significance of what they had seen. The flash was not an eruption of Mercury's magnetic field, but something much more mysterious. Scientists analyzed data from other spacecraft such as Messenger, which had orbited Mercury from 2011 to 2015, and BepiColombo, which had flown past the planet in 2021. They compared Mercury's magnetic field measurements before and after the event, and found that something strange had happened. According to their analysis, about 8.3 tons of sodium had been blasted away from Mercury's surface at a speed of 7 kilometers per second. This is equivalent to the force of an earthquake measuring 5 on the Richter scale. But how did this happen? What caused such a violent eruption on Mercury? To understand this phenomenon, we need to delve deeper into the composition of Mercury. Mercury is the smallest planet in the solar system and is located closest to the Sun. As a result, it experiences extreme temperatures ranging from 430 degrees Celsius to 180 degrees Celsius. These high temperatures can cause various chemical reactions and atmospheric disturbances, which may lead to the emission of gases and metals from its surface. One of the most abundant elements on Mercury's surface is sodium. In fact, scientists estimate that Mercury has the largest sodium reservoir of any planet in the solar system. This abundance of sodium is likely due to volcanic activity in the planet's past, which released vast amounts of the element from its core. However, the origin of Mercury's sodium remains a mystery. Scientists speculate that it may have originated from the Sun and been captured by Mercury's gravity, or it could have formed naturally on the planet's surface through chemical reactions. But how does sodium escape from Mercury's atmosphere? You see, Mercury has a very weak magnetic field compared to other planets, which provides little protection from the solar wind, a constant stream of charged particles flowing from the Sun. When the solar wind reaches Mercury, it collides with the planet's weak magnetic field and ionizes the sodium atoms, stripping them of their electrons and turning them into charged particles called ions. These ionized sodium atoms are then accelerated by Mercury's magnetic field and shot into space. This process is known as sputtering, and it is one of the main ways that sodium escapes from Mercury's atmosphere. In the case of the mysterious eruption in 2012, scientists believe that a combination of factors led to the sudden release of a massive amount of sodium. First, a solar flare, a sudden eruption of energy on the Sun, sent a surge of charged particles towards Mercury. Second, a shockwave from a comet or meteorite impact may have hit Mercury's surface, creating a temporary hole in its magnetic field. And third, unusually high temperatures on Mercury's surface may have accelerated the sputtering process, allowing more sodium to escape. This eruption was not just a one-time event. Scientists have observed similar flashes on Mercury's surface, and they believe that these are signs of other eruptions. In fact, they estimate that Mercury loses about 300 tons of sodium to space every year. This may seem like a small amount, but it is actually significant because it represents a loss of volatile material from the planet's crust. Over billions of years, this could have led to the depletion of Mercury's atmosphere and its transformation from a hot and bubbly world to a frozen and barren one. The discovery of Mercury's sodium loss has raised several questions for scientists to ponder. For example, how long has this been going on? How will Mercury's atmosphere evolve in the future? And is there anything we can do to prevent further erosion? To answer these questions, scientists are using advanced computer models to simulate Mercury's atmosphere and predict how it will change over time. They are also analyzing data from spacecraft such as the European Space Agency's Beagle 2 probe, which landed on Mercury in 2014 and is still transmitting data back to Earth. One of the most exciting developments in this research is the use of artificial intelligence, or AI, to analyze the vast amounts of data being collected by spacecraft. AI algorithms can identify patterns and anomalies in real-time data, allowing scientists to monitor Mercury's atmosphere more efficiently. For example, AI can detect changes in Mercury's magnetic field that may indicate a sputtering event. It can also analyze images from spacecraft to identify new features on Mercury's surface, such as craters or deposits of sodium. Another promising development is the use of machine learning, a subset of AI, to develop predictive models of Mercury's atmosphere. Machine learning algorithms can learn from historical data and make predictions about future events. For example, scientists can train a machine learning algorithm to recognize the precursors of a sputtering event, such as changes in solar activity or temperature on Mercury's surface. This could allow scientists to forecast future eruptions and protect any future missions to Mercury from their effects. The study of Mercury's sputtering has also led to a better understanding of the planet's magnetic field. Scientists have found that the sputtering process creates a thin layer of sodium ions around Mercury, which interacts with the planet's magnetic field to form a magnetosphere. This magnetosphere is one of the thinnest in the solar system, but it is crucial for protecting Mercury from the solar wind. By studying the structure and dynamics of Mercury's magnetosphere, scientists can learn more about the planet's core, mantle, and crust, as well as its interaction with the Sun. One of the key tools used to study Mercury's magnetic field is the Magnetospheric Multiscale Mission, or MMS, a fleet of 4 spacecraft launched by NASA in 2014. The MMS mission is designed to measure the properties of magnetic fields and plasma in space, including Mercury's magnetosphere. The spacecraft use a variety of instruments, such as magnetometers, particle detectors, and cameras, to observe the structure and behavior of Mercury's magnetic field. The data collected by MMS has revealed some surprising features of Mercury's magnetosphere, such as the presence of magnetic holes and tunnels that allow charged particles to escape. Scientists are still analyzing the data and developing models to explain these features, but they may provide clues to the origin and evolution of Mercury's magnetic field. The study of Mercury's sputtering and magnetic field has also led to a better understanding of the solar wind, a stream of charged particles flowing from the Sun. The solar wind is constantly bombarding Mercury and other planets in the solar system, and it can cause a variety of effects, such as auroras, magnetic storms, and atmospheric erosion. By studying how Mercury's atmosphere and magnetic field interact with the solar wind, scientists can learn more about the properties and behavior of this important space weather phenomenon. One of the challenges of studying the solar wind is its variability. The solar wind can change in speed, density, and direction, depending on the activity level of the Sun. For example, during solar maximums, the Sun's activity peaks and the solar wind becomes more intense. By monitoring the solar wind and its effects on Mercury, scientists can track changes in the Sun's activity and forecast space weather events that could affect Earth. So as you can see, the study of Mercury's sputtering and magnetic field has far-reaching implications for our understanding of the solar system and beyond. From the composition of Mercury's atmosphere to the behavior of the solar wind, there is still much to learn from this enigmatic planet. With the help of advanced technology and innovative research methods, scientists are uncovering the secrets of Mercury and gaining a deeper appreciation for the complexity and wonder of our universe. What do you think about this amazing footage? Please share your thoughts in the comments section below. We'd love to hear what you have to say. Thank you for tuning in to watch this video. If you enjoyed it, don't forget to hit that like button and subscribe for more updates on all our latest videos.